Welcome to your June 2018 Regents Review. We're going to go over questions 25 to 37. So starting with question 25, we have the graph f of x equals the square root of x plus 2. So when we type this into our graphing calculator and we look at our table, what we're going to see are some crazy decimals, and they want us to only graph from the domain -2 to 7, which means our graph will not have any arrows. And so on my table, I just need to look at the values from -2 to 7. Now, I'm not going to plot every single point from -2 to 7 because there are some crazy decimals, so I'm only going to plot the nice points. So, for instance, -2, 0 is a good point, -1, 1. I'm going to skip and plot 2, 2, and then 7, 3. So if we plot these points, our graph looks like this weird curve, and again, there won't be any arrows because of the domain restrictions. And so our last thing that we should do is just label our graph, and since it calls it f of x, we can also call it f of x. Now in question 26, we have Caleb that claims that the ordered pairs shown in the table below are from a nonlinear function. Now, if it's a nonlinear, that just means that it's not going to be a straight line. And we're just needing to state if Caleb is correct and explain our reasoning behind it. So one way that we could look at this is we could figure out what's the pattern. So how are the y's going up? So if we look at the y values, it looks like they are being multiplied by 2. And if you graphed this function, it would look like this curve. And so based on a graph, based on the fact that we're consistently multiplying, we know that it's nonlinear. Now we just have to explain it. So one way that you could explain how Caleb is correct is that you could say the multiplying factor of 2 makes this an exponential function, which is nonlinear. You could also say that in order to be linear, it would have to be consistently adding the same number each time, and that's not happening, so obviously it's nonlinear. Now on question 27, when it says solve for x to the nearest 10th, and then it gives us an equation with x squared, the only possible way that we can solve this is the quadratic formula, unless you want to work with completing a square, which tends to be much more difficult. So the quadratic formula is your best bet, and we know that we're going to have to round, and the quadratic formula is also given to us on our reference sheet. So here's the quadratic formula. From this problem specifically, we know that our a value is 1 because a is the number in front of x squared. We know that our b value is also 1 because that is the number in front of x. And we know that our c value is -5 because that is the number not attached to any variable. Now we just have to substitute in to the formula. So when you start plugging into the formula and you end up down to this step where you have -1 plus or minus the square root of 21 all over 2, this is where you can type this into the calculator. And what you're going to want to type in this step is the -1 plus the square root of 21 divided by 2. And you want to do the big fraction and type that all in at once. When you do that, you're going to round to the nearest 10th, and you will get an answer of x equals 1.8. So that is one of your roots. The other answer that you're going to get is by using the subtraction, and so the other part that you're going to type into your calculator is -1 minus the square root of 21 all over 2. And when you type that in, your other answer will be x equals -2.8 when you round to the nearest 10th. So those are the two roots rounded correctly, and that's all you have to do for this problem. Now in question 28, the graph of the function p of x is represented below, and on the same set of axes we're going to sketch the new function p of x plus 2. Now this is tough because we can't exactly type into our graphing calculator p of x plus 2 and expect it to understand what to do. So what we have to remember is whether this is a horizontal or vertical shift. And because we're adding inside the parentheses, everything is staying within the parentheses, we know that it's going to be a horizontal shift. Now what we have to remember next is whether that's shifting to the left or right. And if we think back, adding 2, although it would initially appear to be going to the right, it's actually going to be moving to the left 2 units. So what we need to do is we need to shift each of these points to the left 2 units and graph below. So here's our sketch of our new graph that's shifted to the left 2 units. And if you're still confused as to why it's shifting to the left 2 units, what you could look back at is the original vertex form, which looks like a of x minus h squared plus k, where hk is your vertex, and it also explains how your graph is shifting left, right, up, and down. And so h represents the horizontal shift, whereas k represents the vertical shift of your graph. And because we have this subtraction symbol inside of our parentheses in the actual formula in the original, that's what's causing this plus 2 to appear. So essentially, if we break this down, this x plus 2 was originally x minus a negative 2. But you're never going to write minus a negative. You're going to clean it up and write x plus 2. So if you think back, this negative 2 is what's causing it to shift 2 units to the left. But the subtraction that's already there from the original problem, it's what's forcing it to become an addition symbol in what we see on this question. So for question 29, it says that when an apple is dropped from a tower 256 feet high, the function h of t models the height of the apple in feet after t seconds. And we're going to determine algebraically, keyword algebraically. That means that we can't just graph it or type it into our graphing calculator and state the answer. We actually have to show the work. So determine algebraically the number of seconds it takes the apple to hit the ground. So essentially what's happening is that you're starting at a height of 256 feet above the ground, and you're dropping this apple, and eventually it's going to hit the ground, and we need to figure out how much time has passed. So what you have to realize is that when the apple hits the ground, the height is going to be 0 because you're at the ground level. So what you're going to do is you're going to substitute 0 in for h of t, because h of t represents the height. So what we have here is 0 is going to equal negative 16 t squared plus 256. And now we just have a problem to solve for t. Now there's a bunch of ways to solve. We could do the quadratic formula. We could factor. Or we could get t alone. And I am just going to get t alone. So what I'm going to do is I'm going to subtract 256 to isolate the t. What I'm left with is negative 16 t squared equals negative 256. Then I'm going to divide both sides by negative 16. I end up with positive 16 equals t squared, and the opposite of squaring is square rooting. So if I take the square root of both sides, I have t equals, now when I take the square root of 16, I could get a positive or a negative version for this answer. But I'm only going to keep the positive version. So I'm going to reject the answer that is negative because I can't have a negative amount of seconds that it will take the apple to hit the ground. So what I have here is my time is actually going to be 4 seconds. It's going to take the apple 4 seconds to fall and hit the ground. Question 30 says solve the equation below algebraically, again keyword algebraically, for the exact value of x. So if it says the exact value of x, I will probably end up with a decimal answer, but if I want to be exact, I'm going to keep it as a fraction. So if I look at the start of this, I already see a fraction in my equation. Now, I don't want to have to work with the fraction, so what I'm going to do is I'm going to use the LCD method and just right away get rid of that fraction. And since the only denominator that is currently there is 3, my LCD is going to be 3. So I'm going to multiply every single term by 3. And when I do that, 3 times 6 will give me 18. 3 divided by 3 is 1, and so I'm just left with a 2 there. And now I haven't distributed yet, so I'm going to still keep the parentheses because I'm going to eventually have to distribute that negative 2 to the x plus 5. And on the other side, when I multiply, I will get 12x. Now I have a nicer problem that I can just solve for x. So I'll start by distributing this negative 2. And so I'll get negative 2x minus 10 when I distribute. Can't forget that 18. And equals 12x. Now, when I combine like terms that are on the same side of the equation, I'll end up with 8 minus 2x equals 12x. I want to isolate the x's, so I'm going to add 2x to the other side. So I end up with 8 equals 14x. And the last step that I need to do is divide both sides by 14. So when I do that, my simplified fraction is 4 over 7. And that is how I'm going to keep my final answer because that is exact. Question 31 says, is the product of radical 16 and 4 over 7 rational or irrational? Explain your reasoning. So first, product means to multiply. So we're going to multiply the square root of 16 times 4 over 7. And when we do that, we get a fraction of 16 over 7. Now, because this is a fraction, it's going to be a rational number. And you can say that anything written as a fraction between two integers, and 16 and 7 are both integers, will be rational. Another way that you could explain this is that the product of two rational numbers will always be rational. So make sure that you give some type of explanation explaining that this is a rational number, since you could say because it is not a decimal that goes on forever and has no pattern. You could also say because it can be written as a fraction between two integers with a non-zero denominator, or you could say that it is the product of two rational numbers and that's always rational. So as long as you give a detailed explanation, you should be good with this example. Question 32 says, on the set of the axes below, graph this piecewise function. So with this particular piecewise function, there are two pieces to it. We'll call them A and B. And so I'll show you my tables for A on the left and for B on the right. So if I look at A says I have to graph negative 1/2 x, and my restrictions are that x has to be less than 2. So if I pick a few values that are less than 2, and I type in this into my graphing calculator, I might pick -4, -2, 0, and 2. Now I'm not using some of those other values just because I don't want to have to work with decimals when I graph this. Now I went to 2, but this point using 2 is important, and I might want to circle it because this is going to be an open circle. And the reason that it's open is because there is no equal to symbol underneath the inequality. So that means that my graph goes all the way up to 2, but it can't actually equal 2. So I'll fill in the rest of the table. So I've got -4, 2, -2, 1, 0, 0, and 2, -1. Now, if I look at B, B is going to start at 2, and it says that I'm going to graph x, and I'm going to graph it starting at 2 and using any x value larger or equal to 2. So that means I can go 2, 3, 4, etc. And when I type that in, I'm going to get y values of 2, 3, and 4. And now I'm going to plot these points in graph. So here's the graph for A. I have my open circle. I also have an arrow going to the left because this graph will continue on forever for any x value that's less than 2. And then I have my graph for B, which starts at 2 and goes on forever. And again, I have an arrow only going one direction, this time to the right, because my x values for graph B will go on forever when x is greater than or equal to 2. And just to be safe, I'll label it. Now this is considered one function, and this is called just f of x, so I can label that anywhere. And although they don't ask us this, it's important to understand that this graph is in fact a function because it passes the vertical line test. Since there's an open circle and a closed circle, it's not going to fail the vertical line test at that point too. So it's still going to be considered a function. Question 33 says that a population of rabbits in a lab, P of x, can be modeled by the function, where x represents the number of days since the population was first counted. And we need to explain what 20 and 1.014 represent in the context of this problem. Now, if they ever use the word context, they need you to explain in words talking about the problem what's actually happening. So we have 20 that we need to explain and the 1.014. Now 20 is the y-intercept, and I know this because in an exponential function, the first term outside of the parentheses is always the y-intercept, but they want 20 to represent something with the context of the problem. So 20 is actually going to represent the initial amount of rabbits in the lab. Now the 1.014 is the number in the parentheses, and that tells you the growth factor. So in this case, with the context of the problem, this 1.014 is going to be the rate at which the population of rabbits is growing. And we know that it's growing because if the value inside the parentheses of an exponential function is larger than 1, then we know that it's going to be increasing. So then it says to determine to the nearest tenth, so we need to round, the average rate of change from day 50 to day 100. Well, the average rate of change is the slope, and so we know that using the slope formula, we're going to have to find the change in y's over the change in x's. So the days, day 50 and day 100, well, those are going to be our x's, but we need to find our y's. So we need to plug into the formula 50 in for x, and we need to plug into the formula 100 in for our x to figure out what are the y values at these days. So when we do that, and we plug 50 in for x, we're going to get a pretty long decimal of 40.08000302. I'm just going to keep it at 40.08 for right now. When I plug 100 into the formula in for x, my y value is pretty long with this one too. I end up getting 80.3203328, but I'll just round early to the 100th right now. Now when I do the calculating of the slope, and I calculate 80.32 minus 40.08 divided by 100 minus 50, and I round to the nearest tenth, I'm going to get a slope, an average rate of change of 0.8. And I'm done with question 33. Question 34 says that there are two parking garages in Beacon Falls. Garage A is going to charge $7 to park for the first 2 hours, and then each additional hour will cost $3. Whereas Garage B is going to just charge a flat rate of $3.25 per hour to park. So it says when a person parks for at least 2 hours, write equations to model the cost of parking for a total of X hours in Garage A and Garage B. So we'll have A and we'll compare it to Garage B. So for A is a little bit trickier, and that's because of that parking for the first 2 hours just being $7 and then charging an additional $3 for every hour after that. So for Garage A, I'm going to use Y is going to be the cost of parking, and they told us that X represents the number of hours. So I'm going to start with Y equals, so we're going to have to charge $7 no matter what, plus 3 needs to multiply X because it's each additional hour, but what I have to do here is I have to take away the first 2 hours because I don't want to charge twice since I'm already charging the $7 for the first 2 hours, and that's why I have to subtract 2 from the total amount of hours. And B is a lot more straightforward because that's just $3.25 per hour to park. So that's going to be $3.25 times X is what your Y is equal to, and that's just going to be for Garage B. Now when it says determine algebraically, again keyword algebraically, the number of hours when the cost of parking at both garages will be the same, well, we know that in math the same is just meaning that it's equal. And so what we're going to do is we're going to set these two equations equal to each other and solve for X for the total amount of hours that these two garages will be equal. So I have my 7 plus 3 times X minus 2, that's Garage A. I need to set it equal to Garage B of 325X, and now I have an equation that I can solve. So we will distribute, and we will get 7 plus 3X minus 6 equals 325X. I'm going to combine like terms on one side, and I will end up with 1. I'm going to also at the same step subtract 3X so I can isolate my X's. I'll end up with 1 equals 0.25X. In my last step, I just need to divide both sides by 0.25. And I'm going to end up with X equals 4, and we're talking about 4 hours specifically. So, it's going to take us 4 hours for when the cost of parking at both garages will be the same. So question 35 is having us graph on the following XY axis the following system of inequalities. And in order to graph these, we need to make sure that Y is alone. So with the top inequality, when I isolate Y, I'm going to have to subtract 3x from both sides first. And so when I do that, I'm going to have 2y is less than or equal to negative 3x plus 14. Then I need to make sure that I divide every single term by 2 so that y is completely alone, and I will end up with y is less than or equal to negative 3/2 x plus 7. My other graph, my other inequality, when I get y alone, I'm going to first subtract 4x from both sides, and when I do that, I'm still left with negative y is less than negative 4x plus 2. Then I need to divide every single term by negative 1 so that y is alone. When I do that, when I divide by negative 1, I need to flip that inequality so it's now a greater than, and its y is greater than 4x minus 2. So here's the graph of y is less than or equal to negative 3/2 x plus 7. It is a solid line because of the equal to, and I also have to remember that because it's less than, I need to shade below. Now the graph of y is greater than 4x minus 2 needs to be a dotted line because there is no equal to, and it's greater than, so I need to be shading above. And the solution set, where the double shading occurs, I can draw a nice big S. Then we have to answer if the point 1, 2 is in our solution set and explain our answer. Now it might be hard to tell from my graph, but 1, 2 is going to be directly on the dotted line. And because it's on the dotted line, this point cannot be in the solution. So anything on the dotted line is not included in the solution set. That's one way of explaining it. Another way to explain it would be to show that when you check the point 1, 2 in both inequalities, it will only work with one of the checks, and therefore it can't be in the solution set because it doesn't work for both inequalities. So my explanation just says that a point on the dotted line is not included in the solution set because a dotted line has either a greater than or less than symbol, and therefore it's not equal to. Question 36 says that the percentage of students scoring 85 or better on mathematics final exam and an English final exam during a recent school year for 7 schools is shown below in the table. And we need to write the linear regression equation for these data, rounding all values to the nearest hundredth. Now, the linear regression equation is the same thing as the line of best fit, and what you're going to do is you're going to type these values into your graphing calculator, into your data and statistics in your lists and spreadsheets, and type in mathematics into list A, the English scores into list B, and then you're going to go into your menu, choose the statistics choice, and then stat calculations, and then I believe it's choice 3, which says linear regression mx plus b. And from there, you're going to see your slope, your m value, and your y-intercept, your b value. And when you put those two things together and you round appropriately to the nearest hundredth, your equation is going to be y equals 0.96x plus 23.95. Now the next part of this says to state the correlation coefficient of the linear regression equation to the nearest hundredth and explain the meaning of this value in the context of the data, which again means that we have to talk back about the actual problem, in this case dealing with mathematics and English scores. Now on the same screen that has your slope and your y-intercept for the line of best fit, it will also have your correlation coefficient, otherwise known as your R value, and to the nearest hundredth, our R value is 0.92. Now, since this R value is close to 1, that means that there's going to be a strong correlation between students scoring 85 or better on their math final and their English final exam. So what we have to remember with this is that the closer the correlation coefficient, the R value, is to 1 or -1, the stronger the relationship. But once it gets closer to 0, then it becomes a weaker relationship. And when it talks about the context of the data, you really have to go back, reread the problem, and make sure that you're answering in terms of the actual problem. So in this case, the math and the English scores of students scoring 85 or better. So our last question, number 37. Dylan has a bank that sorts coins as they are dropped into it. A panel on the front displays the total number of coins inside as well as the total value of these coins. The panel shows that 90 coins with a value of $17.55 is inside the bank. Now Dylan only collects dimes and quarters, and we need to write a system of equations in 2 variables or an equation in 1 variable that could be used to model this situation. So that means I'm going to use let statements to talk about what I'm representing x to be and what I'm going to represent y to equal. So I'm going to say that x is going to represent the number of dimes, and I'm going to allow y to represent the number of quarters. So if I have a total amount of 90 coins, then I have x amount of dimes plus y amount of quarters, and together they will add up to 90. And when I talk about the fact that there are $17.55 inside the bank, then that means I have 0.10 times x, because there's 10 cents to represent a dime, plus the value of a quarter is 25 cents, so that needs to be 0.25y, and that's going to equal my total cost of $17.55. And what we have to remember here is that formula, the cost times quantity equals total. Now for the next part, it says that using your equation or systems of equation, algebraically, determine the number of quarters that Dylan has in his bank. So we need to find, in this case, y for the number of quarters. And we're going to do that with the elimination method. And so what we want to do is we want our x's to eventually eliminate when we add the 2 equations together so we can solve for y. So if we want our x's to eliminate, that means that we're going to multiply this top equation, this x plus y equals 90 equation, we're going to multiply that by negative 0.1. And you'll see what happens in the next step. So I've multiplied the top equation by negative 0.1. I have not changed the bottom equation, and now, using the elimination method, I'm going to add these 2 equations together, because when I do that, my x's will eliminate, my y's will add up to 0.15y equals 8.55. Now I just need to divide both sides by 0.15 to get y alone, and I end up with y equals 57, and the 57 represents the number of quarters that Dylan has. So with this next part, we're still on question 37. It says that Dylan's mom told him that she would replace each of his dimes with a quarter, and if he uses all of his coins, determine if Dylan would have enough money to buy a game priced at $20.98 if he must also pay an 8% sales tax. And then we have to justify our answer. So first we'll talk about how much money Dylan's going to have if his mother replaces all of his coins, and remember he had 90 coins, with quarters. And so we can multiply 90 with 25 cents, this 0.25, and that means that Dylan is going to have $22.50 to work with. And we'll see if that's going to be enough to pay for this game once we also include the sales tax. So to figure out the sales tax, we're going to start with how much the game cost, this $20.98, and we're going to add that to the cost of the game, $20.98, once we multiply it with this 8% sales tax. And 8% as a decimal is 0.08. And if you're confused as to where I got that, I took 8%, I divided it by 100 because all percents are out of 100, and when I do that, I get 0.08. Now, when I add all these together and I multiply, I end up with 22.6584. Now, if we're talking about money, that's going to have to round, and so that's going to be around $22.66, and this is talking about the cost of this game. And this $22.50 is how much money that Dylan currently has. So he has $22.50, but the game will cost him $22.66. So what we need to explain is that even if Dylan's mom replaced all of his dimes with quarters, Dylan's amount of $22.50 would not be enough to cover the cost of a game with the sales tax. So again, in the end, Dylan does not have enough money for the game once we include the tax because he is still 16 cents short.